Okay, so today we're going to go back over our sine, cosine, and tangent functions. You guys actually should have some previous knowledge on all three of those because you used them when you were in geometry. But from here, I want to make sure that we review them and we understand exactly what we're talking about. What is the first thing that comes into your mind when you hear sine, cosine, and tangent? Go ahead and say it. SOHCAHTOA. That's what I've heard all day long. We have SOHCAHTOA. I'm the first to admit that I can't spell SOHCAHTOA, so I have to go through my trig ratios to even spell it correctly. So it doesn't help me a whole lot, but hopefully if that's the way you remember it. We should know that sine is equal to, what's the O and the H stand for? Opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Now, I have a right triangle drawn here. Why do I know that I have to have a right triangle? If I'm going to use the sine, the cosine, or the tangent, why do I have to have a right triangle? Anybody? Well, what's the H stand for? A hypotenuse. In order to have a hypotenuse, we have to have a what? A 90 degree, because the hypotenuse is always across from the 90-degree angle. Now, there are some of us who are mature enough to admit that we need a way to stay organized about that. And so I have told students before that they may want to star the hypotenuse, they might want to circle the hypotenuse, whatever they need to do to automatically remind you of the hypotenuse. That's, in this case, C is going to be my hypotenuse. Now, first we're going to look at angle A and talk about the relationships that we have for angle A. If I want to write the sine of angle A, I first am going to write that the sine of theta, meaning the sine of any angle at all, is equal to opposite over hypotenuse. The sine of angle A, however, what side is across from angle A? A. And what is my hypotenuse? C. Cosine of any angle at all, and so that's why we use theta, cosine of theta is equal to adjacent over hypotenuse. What is the adjacent side for this particular angle? B. So it's going to be B over C. Cosine of A is going to be B over C. And then tangent of any angle at all is opposite over adjacent. It's hard to read my writing. And so tangent of angle A, the opposite is A over B. Opposite over adjacent. Now, just as I can write all of my relationships, sine, cosine, and tangent of angle A, we can also write all of the relationships for angle B. Somebody tell me what the sine of angle B is equal to. Brian, what's the sine of angle B? Okay. The cosine of angle B, what do you get, Brooke? We're down here at angle B. What's my cosine? A over C, because it's adjacent, right? And then the tangent of angle B, tangent is always opposite over adjacent, Kyle. So what's my relationship for the tangent of angle B? The opposite is, okay, and what's the adjacent? So it's going to be B over A. Now the reason we need these three relationships is they allow us to find different side measures and different angle measures when we are not given everything that we need to know. If we have this particular triangle, go ahead and write it down for me, please. We know it's a right triangle. What do we have an angle measure and we have a side measure. This is actually going to be side A, and this is actually going to be side B. Okay, so if we have this particular triangle and we want to find the other sides and the other angle, I'm going to get myself organized. I'm going to write what's given in green. So I have angle A, I have angle B, and I have angle C. And then I've got side A, side B, and side C. Angle A, we don't have, it's not given. Angle B is given as 50 degrees, and angle C is given as 90 degrees. The only side that is given is C, so it's given as 32. Can I find angle A pretty easily? We should recognize that in any triangle, the interior angles are going to equal 180 degrees. And so this is going to give me 40 degrees. Now, if I want to find side A, does it matter whether we use A or B? No. I'm going to use A in order to find side B. What's the relationship between angle A and side B? They're adjacent. So if I use which one of my I just said it. Which one of my trig functions does adjacent over hypotenuse? So we're going to do cosine of theta is equal to adjacent over hypotenuse. And so the cosine of A is equal to B over what? 32? And I actually should have plugged what in for A? What's my angle measure for A? 40 degrees. I can plug that in as well. So now I have 40, cosine of 40 equals B over 32. How do I get B by itself? Multiply both sides by 32. Absolutely right. Now get out your calculators. We are saying that B is equal to 32 cosine of 40 degrees. So since it's degrees, what are we going to do in order to find, what do we have to do to our calculator if we're using degrees? Yeah, check your mode. Everybody hit mode and check and make sure that your calculator is in degree mode. If it's not in degrees, well then highlight, if yours is in radians, then highlight it and make sure that it is now in degrees. Now, everybody put in 32 cosine of 40 and tell me what side B is equal to. 24.5. So this side is equal to 24.5. Now, if I wanted to find side A, could I also use angle A? Could I use angle A? What's the relationship between angle A and side A? Opposite, there you go. Could I use B? I could use angle B as well. What's the relationship between angle B and side A? Adjacent. So it doesn't matter which one you want to use, just to give us some color, I'm going to use angle B. Angle B, the relationship with side A, once again, is cosine of theta equals adjacent over hypotenuse. So cosine of 50 is equal to A over 32, and I'm going to multiply both sides by 32. Please tell me what you get for angle A, because these are going to cross out. 32 times the cosine of 50. 20.6? That's what I got. Now I'm just going to throw in a quick statement. Should we have used tangent? Tangent would have done opposite over adjacent. Would it be a good idea to use tangent? We have a tangent measurement of 24.5. Do you think we would get the same answer? One of my students in 2 classes ago did that, and his answer did not round to the exact same answer that mine did. The reason that his answer did not round correctly is because what did we do to the 24.5? Rounded it. Do we want to use a rounded answer in order to find another answer? No. You always want to try to use your given. If it's possible to find your answer with what you initially started with, you want to do that. All right, let's go to this triangle. In this triangle, we're going to be solving for the angles. We're not going to be solving for the sides. Could we solve for this third side? We have 2 sides in a right triangle. What can we use? Pythagorean theorem. I'm sure you know how to do that. I'm going to skip to my angles. If I want to find angle A, what is the relationship between the 8 and angle A? And what's the relationship between A and 13? So this is going to be which one of our trig functions? Tangent of any angle is equal to opposite over adjacent. So tangent of A is equal to 8 over 13. But I don't want the tangent of A, I want A. So does that mean I take the tangent of both sides? Put tangent of 8/13 in your calculator. Put the tangent of 8 divided by 13. What do you get? Is there any way that this angle measurement is equal to 0.01? No. So, once again, just like your calculator was set up for your natural log and your e, or your 10 to the whatever and your log, or x and x squared, what do you think? How do you get rid of a tan? Look at your calculator. Tan to the -1. So you are going to do the inverse of the tangent to make those cancel out. Oops, sorry. Those are going to cancel. So angle A is going to be tan to the -1 of 8 divided by 13. That's just going to be equal to what? 31.6 degrees, because we're in degrees. 31.6 degrees. Now, my other students fought with me over and over about whether we should find angle B or not, because what could we do to find angle B? We could just subtract it, but let's check and see. It should be that the tan of B is equal to what? 13 over 8. Try that out. If you put in, angle B